Welcome back, student. Welcome to the class. So now we will discuss Finkelstein reaction. It is also called as halogen exchange reaction. Alkyl chloride or bromide, when react with NaI in acetone, they give you the corresponding alkyl iodide. NaI is soluble in acetone, while NaBr and NaCl are not soluble in acetone. So what has happened that after the formation, the NaCl and NaBr, they do not react back. Why? Because they are insoluble. They settle down at the bottom. So otherwise what can happen? Because iodide is also a very good leaving group, the reaction can be reversed. Okay, so remember in your memory you have to keep that why we have to use acetone, because acetone will make sure that NaI remains soluble, while NaCl and NaB are formed, they remain settled down at the bottom. That is very important reaction, Finkelstein reaction, that is also known as halogen exchange reaction. Now in Finkelstein reaction, if the alkyl halide is tertiary in nature, then we use NaI in carbon disulfide in zinc chloride. Okay, in that case you do not use acetone, use CS2. So carbon disulfide dissolved in NaI in anhydrous at NCl2 to give you the corresponding tertiary iodide. For vinyl halide especially, okay, the Ki is used in pans of nickel dibromide and zinc. Okay, so Ki dissolved in nickel bromide and zinc solution, and Cl is replaced by what? Cl is replaced by iodine. So that is in case of vinyl halide. Now the next reaction is Hunts-Dicker reaction, that is also known as Borodine Hunts-Dicker reaction. Okay, and is very popular reaction to prepare long chain alkyl bromide. It is a free radical reaction. Decarboxylation means loss of CO2. Loss of CO2 takes place in this reaction. The silver salt of a carboxylic reaction, when react with bromine in CCl4, give alkyl bromide. It is also known as Hunts-Dicker reaction. Now what happens? Silver salt of a carboxylic acid react with bromine in CCl4 to give you RBr. This CO2 loss as CO2 and silver will form silver bromide. Look at the reaction, how it happens. That the negative charge of this carboxylic salt will attack bromine to give you a OBr bond. After that, in pans of CCl4 and heat, what happens? This OBr bond undergo homolytic bond fission and free radicals are formed. Okay, so Br is, after that what happens? After the formation of this electron, free electron, and this bond, this particular bond, it undergo homolytic cleavage again, and this CO2 is being obtained, and along with that you have a formation of alkyl free radical. This alkyl free radical reacts with second molecule of this acid to give you RBr, and now this molecule is again that is available to you to the formation of the next R. Are you okay with that? Now look at that. This is silver benzoate. It reacts with bromine in CCl4 to give you bromobenzene. Silver salt of the carboxylic acid, when treated with iodine, it leads to the formation of an ester. That is very important. Okay, that in if you take bromine, you will get a bromoalkane, but if you take iodine, you will get an ester. This is known as Simononi reaction. Look at that. Silver salt of carboxylic acid react with iodine in CCl4. Reflux means what? Reflux means constant boiling. It means what? Constant boiling. In the previous class I told you. And what happens that you have formation of an ester. Here also loss of CO2 happens, so that is also involved decarboxylation. Okay, sure about that. But an ester is being formed here, and you had the formation of silver iodide as one of the product. Now we have to look at the preparation of aryl halide. The first reaction is the Sandmeyer reaction. Now what happens in Sandmeyer reaction? This is aniline. Aniline reacts with nitrous acid. Now nitrous acid can never be prepared and stored. It is always prepared in the solution wherever it is required. What happens wherever nitrous acid is required? I am repeating, wherever nitrous acid is required. Wherever nitrous acid is required, it reacts with HCl, sodium nitrite react with HCl to give you nitrous acid and NaCl, and it is present in solution where it has to be consumed there itself. You produce the HNO2 in the condition where it is consumed there by itself. Okay. Now what happens here? It forms benzene diazonium salt. How it is forms? Now look at the mechanism of diazotization. Nitrous acid, this react with H plus because plenty of HCl is there now. So one of the H plus is given by HCl. The lone pair present on the OH of nitrous acid, it attacks H plus, and you had the formation of protonation of oxygen. After that, a positive charge develops on oxygen. To remove that positive charge, the bond pair between nitrogen and oxygen, it transforms towards oxygen, and water is being eliminated, and you have the formation of what? This is called as nitrosonium ion. Nitrosonium ion. That nitrosonium ion will give you what? It will give you what? It will give you a required electrophile. Now that required electrophile, it reacts with aniline. Aniline has presence of one lone pair on nitrogen atom. This lone pair present on nitrogen atom, it attacks the nitrosonium ion because nitrosonium has incomplete octet, so it is an electrophile. Why it is electrophile? Because nitrogen does not have complete octet. I am repeating once more. NO, nitrosonium ion is electrophile because nitrogen does not have a complete octet. So this lone pair becomes a sigma bond, and due to that what happens? A positive charge develops on nitrogen. When this positive charge develops on nitrogen, the bond pair becomes lone pair. The bond pair becomes a lone pair, and the H plus produced is immediately attacked by oxygen, and you have protonation of oxygen here happens. Okay. After that what happens? That the lone pair present on nitrogen, okay, it becomes a pi bond, and this pi bond becomes a lone pair to remove the positive charge present on the oxygen. Okay. From where this positive charge comes? From here. When this lone pair becomes a sigma bond, oxygen got positive charge. Okay, this pi cloud becomes lone pair. Now this lone pair immediately attacks the proton. Why? Because after the lone pair becomes a pi bond, the nitrogen develops a positive charge. So what has happened? Lone pair comes back again to nitrogen. Now after that what happens? That lone pair transforms into a pi bond. Okay, transform into a pi bond, and water molecule is lost. So you have formation of benzene diazonium salt. What you have? Benzene diazonium salt, and it is one of the most reactive organic compound. Okay, remember that benzene diazonium salt is stable only at very low temperature, 0 degrees Celsius. Okay, up to 2-3 degrees Celsius it is also stable, but after 4 degrees Celsius it becomes spontaneously decomposes. Now what happens after the formation of benzene diazonium salt? These reactions are called as what? They are called as Sandmeyer reactions. They are what? Sandmeyer reaction. What happens in Sandmeyer reaction? That benzene diazonium salt, when react with cuprous chloride, it transforms into chlorobenzene. With cuprous bromide, it will transform into bromobenzene. With cuprous cyanide, it transforms into cyanobenzene. So these three reactions are very, very simple reactions. Okay, sure about that? Cu2Cl2 with chlorobenzene, Cu2Br2 bromobenzene, CuCN will use cyanobenzene. Similarly, with Ki, it will give you iodobenzene. Now, the reaction of fluorobenzene is known as Bulge-Skyrman reaction. When benzene disonium salt react with HbF4, it gives you N2 plus BF4 negative, which on strong heating will give you fluorobenzene. Will give you what? Fluorobenzene. That is very, very important. Are you sure about that? Now, when benzene disonium salt react with this is hypophosphorus acid. This is hypophosphorus acid. So when it react with hypophosphorus acid, it gives you benzene. When it react with water, it will give you phenol. Okay, and similarly when it react with D2O, it will give you what? OD. That is phenol also, but here what can you get? Here you will get the isotope OD in presence of OH. Okay, so that is what. So heavy water will give you what? It will give you OD. Now, one more example is Gattermann modification. What is Gattermann modification? That when benzene disonium salt react in place of cuprosamide, just take copper powder along with the acid. Okay, so when copper powder heated with disonium salt in presence of HBr, it will give bromobenzene. With HCl, it will give you chlorobenzene. This is very, very important. This is called as Gattermann modification or Gattermann reaction. Okay, it is a modification from the Sandman reaction. Similarly, when it treated with tin chloride in HCl, it will give you phenyl hydrazine. It will give you phenyl hydrazine. When it reacts with zinc in HCl, it first gives you phenyl hydrazine, which on further reaction with zinc in HCl will provide you aniline. It will provide you aniline and ammonia. Aniline and ammonia, that you have to memorize. Okay, that is very, very important. Now look at the resonance stabilization of the benzene disonium salt. Benzene disonium salt means NO2 plus is electron withdrawing in nature. Why? Because nitrogen carry positive charge here. So what happens? This pi cloud will move towards the nitrogen atom, and this pi cloud transform as a lone pair. Okay, so look at this. So this nitrogen got what? This nitrogen carry two lone pair and a negative charge. Okay, positive charge will develop at ortho position. So this pi electron will go towards this. So positive charge will appear at ortho position. After that, pi electron goes from this position to the positive. So again, ortho position will attain a positive electron. After that, the nitrogen carbon double bond becomes pi bond, and this lone pair again become pi bond. Okay, sure about that? So you have to memorize that. Okay, why it is happening? Because of the electron withdrawing nature of N2 that is present on the benzene ring. Now next is very, very important, that is the direct halogenation of benzene. The direct halogenation of benzene is occur via Friedel-Crafts. This is called Friedel-Crafts chlorination or halogenation. Okay, benzene react with chlorine pans of AlCl3 to give you chlorobenzene. Now when chlorine react with AlCl3, halogen that is attached to the benzene ring. Now this is an excellent example of electrophilic substitution reaction. The reaction involves mainly three steps. Number one is the generation of the electrophile. The second step involves electrophilic attack on the benzene ring to give a sigma complex. And third step is the electrophile H plus leaves the benzene ring. So you can say chlorine plus electrophile enter the system and electrophile H plus leave the system. So look at that how reaction happens. AlCl3 being a Lewis acid because it is incomplete octet. Aluminium has only 6 sigma electrons around itself, so aluminium has incomplete octet. So in order to complete the octet, chlorine acting as a Lewis base attacks the aluminium and this lone pair become a sigma bond. Okay, so this chlorine will acquire a partial negative charge, the chlorine will acquire a positive, and ultimately the bond is broken and you have the generation of Cl plus, that is electrophile in this case. So this electrophile Cl plus is immediately attacked by benzene ring, which is electron rich in nature. Why it is electron rich? Because it has pi electron. So it has 6 pi electrons, which are electron rich species. So this pi will attack the H plus. Now look at that. The position where the chlorine get attached, now that carbon become sp3 hybridized. So when this carbon atom become sp3 hybridized, it does not have any p orbital available vacant or has any p orbital which has the availability of either pi electrons or lone pair. So it means that this carbon become sp3 and no more will remain in conjugation. Okay, so what happens? Except this carbon atom, all other 5 carbon atoms, they will be involved in resonance. How? Look at that. The positive charge appear in this carbon, this sigma pi electron will go towards that and positive charge will come here. After that what happens? These pi electron will go from here to here, okay, and you have development of positive charge here. So this is known as what? This is known as a sigma complex. Okay, look at that from this 1, 2, 3, 4, 5. So all these 5 carbon positive charge has been spread, and particularly at ortho and para position of chlorine, these charges are mildly. Okay, sure about that or not? So what has happened now? The conjugate base, that is AlCl4, it will attack the proton and you had the formation of chlorine. Now here the loss of H plus from the ring is what? Is not the rate determining step. So it is very fast reaction. So what is the rate determining step in here? The rate determining step here is the sigma complex resonance. So the factors which will stabilize the sigma complex will determine the rate of the reactions. Okay, so a positive charging is developed at the sigma complex. So any species which will decrease the development of positive charge or release the electron towards the benzene ring, they will stabilize the sigma complex. So one can say that electron releasing group will promote the electrophilic substitution reaction, while electron withdrawing group will deaccelerate the reaction. Now look at the energy level diagram of this. So what has happened that this is the ground state of benzene and this is the formation of the product. So what has happened? So here it is the benzene undergo transition state 1 and transition state 2, and that is intermediate 1. Okay, what is that? Transition state 1 is this. Look at that. The attacking nucleophile is just beginning to form the bond. Okay, what is transition state 2? The hydrogen is just leaving the system. And what is intermediate here? Intermediate is the sigma. It is the conjugation of the sigma. It is the conjugation of the sigma. So TS1 is what? When electrophile bond is just forming with the carbon. And what is TS2? When the hydrogen bond is just broken and it is leaving the benzene. So TS1 is the involving the partial formation of the electrophile, okay, and complete retention of the hydrogen. While in TS2 it is reverse, it is the partial breaking of the hydrogen and complete formation of the electrophile and the carbon bonding. Okay, so that is very very important, and this is the product form after the leaving of the proton from the intermediate sigma complex, and you have the aromatic system back. Remember that in between the reactant and product, the sigma complex and the various intermediate, they do not carry any aromatic character. Why? Because one of the carbon atom becomes sp3 halide. Okay, sure about that. Now look at the next. What happens now? This group that is called methyl, it will activate the benzene ring. So when chlorination happens, it will happen mainly at ortho and para positions. Why? Because CH3 is what? CH3 is electron releasing in nature due to hyperconjugation and inductive effect. I am repeating once more. CH3 is electron releasing in nature due to two factors. One is inductive effect, plus psi effect, and second is via hyperconjugation. Okay, so you may say that para product is dominating because of the steric hindrance given by CH3. Similarly, but if you take the same reaction in place of AlCl3, if AlCl3 is not present, it means the first step, that is the initiation of the formation of the electrophile, does not happen. So if you use ultraviolet light, then what happens here on this allylic carbon or benzylic carbon, free radical substitution will take place and give you benzyl chloride. Similarly, if you have formation of chlorobenzene and you react with chlorine being deactivating nature, the reaction becomes slow. But despite the slowness of the reaction does take place, and you had the formation of 1,2-dichloro and 1,4-dichlorobenzene. These two products are formed, but the rate of formation of these products is very slow due to the deactivation nature of the. Now dipole moment of chloromethane is better than fluoromethane because dipole moment is product of bond length and charge. Now due to the very short bond length of CF, so CF bond length is short. So due to that only chloromethane has greater dipole moment than CH3F. Now if you look at the various dipole moment of these halobenzenes, what can you say? It is the tendency to form back bonding. Fluorine, the lone pair present in 2p orbital, while in case of iodine, the lone pair present in 5p orbital. So what happens? p-pi back bonding, p-pi back bonding with the benzene ring, is maximum in case of fluorine. So due to that what happens? The dipole moment of, or you can say bond length, decrease. Okay, so decrease in bond length will happen in decrease in dipole moment. Okay, sure about that. Although what can you say? You can say that carbon fluorine bond should be the most polar bond, but despite being that, it is not so the case. Why? Due to the formation of p-pi bonding between the carbon atom of benzene and between the lone pair on the fluorine.